I think our intros did a great job of sort of talking about work that we and our team of collaborators have already done. I'm curious what all of us are most excited about looking forward. What are sort of the open questions? Why are they important? What are their impacts?
Of things that we're working on, or
yeah,
other people?
Or other people, and either.
So something I've started thinking about lately is uncertainty visualization is really, really hard to do. It's very difficult to just from a technical perspective put together the visualization you want with the uncertainty that you want. And I've been starting to think about what would it look like to have a grammar of uncertainty visualization that allows you to put together with pieces maybe attached to something like a graphical model, the uncertainty of the results of some model or something like that. I think that would be very powerful. It would make it actually possible for people to regularly put uncertainty in their visualizations. I think one of the reasons we don't is that it's just annoying.
Yeah.
Yeah, I'm actually just going to point at the two lovely gentlemen next to me and say these are uncertainty and the sort of explanation of AI and machine learning are two huge problems. And for me, when I work with the scientists, uncertainty comes up all the time. And when I work with the astronomer, it's like, well, it's 10% this way or that. But when it comes to a heart disease diagnosis, the uncertainty is literally a life or death situation. And presenting that to the doctor is incredibly important. And then a lot of these algorithms I use with the doctors for decision support are lovely machine learning algorithms, and trying to explain to them what's going on and actually build trust. And I'm working very hard, and it's challenging to build trust and sort of explain what's happening on the back end is quite challenging.
Yeah, I agree. And I also think that what you said about the interdisciplinary collaboration is really critical. And I think you can probably see this in all of our work, that there's a huge power in bringing two fields together. Certainly in machine learning, I think there are questions of what can we learn from what these machines are doing that might tell us about human psychology. And then, of course, in any particular application area, you obviously have major overlaps. So I do think this idea of figuring out how we bring people together from different disciplines to collaborate around visualization is critical. That's one of the reasons why making it easy for people to make visualization is really nice. In some sense, one good goal of the visualization expert is to make themselves obsolete. And I think that in itself is a very exciting prospect.
Yeah. Do we have questions in the audience? Dave over. Yeah.
Implicitly or explicitly stated in your presentation, it seems that visualizations are for people, and hence designing good visualization for people is actually a very, how to say this correctly, there's a social aspect to the whole thing. So what is a systematic way, from your perspective, to involve that social aspect in the let's say whatever each one of you guys are doing, be uncertainty visualization or be scientific visualization or machine learning teaching, or actually providing language infrastructure?
Yeah, so one thing I would say is that it's very important to embed visualizations in social systems. And this is where the web, I think, was a huge accelerant in progress in visualization, because once you make these things public, people can collaborate with them. And this is something that at past moments in my career I've focused on a lot, is figuring out how you can sort of use a visualization to spur collaboration, communication. And there's a lot of evidence that it really can do that. So I think that would be one answer to the question. The other thing that I would say is that we have to be comfortable in these sort of social aspects of visualization with less quantifiability than we want as engineers. That there are parts of the visualization world, for example, when we talk about the perception of color, where we could actually write down equations that make very strong predictions. There are other cases, and in the cases you mentioned, where I think we have to be comfortable with ethnography, with some guesses, with sort of the level of rigor of urban planning, rather than, say, bridge building.
I think that's a really good summary. And yeah, a lot of that sort of getting this sort of social component is also talking with lots of people. And when I do the scientific visualization, it's like talking with scientists and getting them involved and sort of almost marketing self-focus groups to sort of get feedback is like a whole nother aspect of it from my perspective.
Yeah, and I think that one of the things that I'm increasingly seeing as important is sort of storytelling and visualization, right? And I know you've done work looking at that, and I think that is a really important understanding, not just visualization for exploratory data analysis, but visualization for communicating the results to someone else. And when you start getting into that, there are a lot of different tools you need in your toolbox, coming from things like journalism, in terms of how you actually communicate an idea to someone in a way that they remember and understand it.
Yeah, and I would just add a little bit to what Martin said, which is, a lot of the visualization community looks at a lot of tool building, and increasingly what I've really appreciated about our community is folks have started to, open source their projects and things like that. But there's a step beyond that, which is, we don't stop at just open sourcing it and putting it on GitHub, but actually reaching out to specific constituencies that we think these tools are most useful for, and putting in the extra effort that often dwarfs the effort we put in the initial research project by at least an order of magnitude. So things like documentation, building examples, answering questions, et cetera, et cetera. But once you do, you sort of see the network effects that we're starting to see with our work around Vega. You start building this ecosystem of users, and then they become your evangelists. And then that message starts to spread. Yeah.
Oh, you asked about research areas or unanswered questions. It seems to me as an outsider in visualization, that a significant question is, if you're going to produce the tools and back out of the picture, you're going to have to include a significant amount of understanding of what constitutes a good visualization versus what doesn't, that doesn't involve back and forth iteration between the developer of the visualization and the recipient of the visualization. And that's going to be non-trivial to start with. It's going to be context dependent. I mean, the doctors have different levels of or acceptability than the astronomers. Isn't that a significant obstacle to the objective stated of getting the tools out and getting out of the way?
So certainly, and a lot of folks have started to do work along this vein. I know, Michelle,
Yeah, I was going to say the interesting question of sort of how you build an effective visualization. People who work on visualization evaluation and perception cognition, that's sort of like a big thing. I've worked with Dr. Oralova here at MIT, and her group has been doing tons of wonderful work, and Zoe Belinsky, and doing things like saliency algorithms and saliency models based on tons of user studies and training data sets. So you could upload a static image of a visualization. The models can tell you this is where people pay attention and give best estimates of how intelligible or not intelligible it is. So there's a lot of movement around how you do this in a very systematic, modeled way. And then there's also just a lot more sort of domain specific, how can we make this effective?
Yeah, I also want to add something that might be a little heretical, which is that I think while it's very important to do the right visualization, and there are definitely degrees of good and bad, very often the best thing is just to start doing visualization. And in general, I think even a mediocre visualization can be really, really good, very effective. If you look at some of the famous visualizations throughout history, if you look at Florence Nightingale's work to sort of promote the importance of hygiene on the battlefield, which saved millions of lives. Honestly, you could really poke holes in a lot of the perceptual aspects of that, but it worked. It really worked. And in fact, even more recently, one thing that I've noticed is that very often you'll see a scientist in a field who's not necessarily that connected with the visualization literature will just on their own create something that maybe doesn't do everything perfectly, but it's usually incredibly effective. For me, the biggest thing is that people should be able to iterate quickly. And that's often doing is the best way to get the kind of literacy you're talking about, as well as seeing. I think the other thing that speaks to what you're talking about is at one point visualizations were rare. Today, if you browse the New York Times, you'll probably see an excellent visualization. So we have lots of good examples to guide us.
I think that the other thing that I would add on is that I think one reason why at least a number of people in the visualization community are kind of obsessed with grammars of visualization or declarative visualization specifications is that once you have something like that, you can start actually talking about how you systematically evaluate a visualization specification to determine things like how effective it will be. And so the sort of classic examples of this are things like the grammar of graphics and what we know about different visual encodings of different types of data can at least tell us, in a visualization with a small number of variables mapped onto a couple things like position and color and whatnot, we can make systematic choices there very easily where we can say this is going to be the best thing, at least perceptually. And I think the thing that excites me about things like Vega Lite is the idea of being able to do that with interactivity. And for me, thinking about a grammar of uncertainty visualization, being able to do that with uncertainty, right? That's kind of one of the reasons why we do that.
And maybe we'll take one last question. Yeah.
Those were beautiful but overwhelming. Can you speak about visualization expert recommendation systems, perhaps like IBM's Pixie Dust, which is machine learning based, or other things that will help?
Was there something specific you wanted to know, or?
The existence of expert systems that will help me in figuring out what visualization to do, or like IBM Pixie Dust, it looks at the data in one click, it makes its best guess. As to
So this is an extremely active area of research. The Voyager tool I showed you, for instance, is sort of one of the real key systems in this area. And what underlies it is sort of a query language over the space of visualization, sort of along the lines that Matt was talking about. So it sort of systematically enumerates all the possible Vega Lite visualizations you might have for a given query. Say I want to visualize price against geographic area or something like that. And then using the information we have of which visual encodings are perceptually effective for what kinds of data types and so forth, it ranks and clusters them and prunes them and then recommends them to users. So I know that folks in the database community are also looking at ways in which these recommendations can be embedded directly into database systems and operate at scale. Sam Madden here at EECS and CSAIL is looking at that with some of his work as well. I know that Martin's group, you guys have.
Yeah, so in Google Spreadsheets, there's actually a way that you can automatically get a chart for your data. And there's this is something my group worked on. And there are a couple of interesting aspects of that. So one is that a lot of the academic work tends to assume as given the data, like you have a clean table. Data in a spreadsheet is never like that, or almost never. One thing that we discovered is that some of the messiness of that can actually be useful. Like if you have a total row, that gives you a clue to the intent behind the analysis. And you shouldn't just delete it. You should delete it and remember it was there. There's another really interesting thing that comes up, which is that when you do this, you can come up with rules as a visualization, someone who's recommending the visualizations that you think are the right rules. And then you can measure, do people take those recommendations or do they revert them? And in some cases, there are things that we're pretty certain about from perceptual and social aspects, that a certain type of graph, maybe a pie chart in a certain circumstance, is not the right graph, but that is what people want. And then you're faced with a choice. You're like, we know what people want. We know what the expert opinion is. Which do we do? I would contend that is not a trivial choice, in fact. A lot of people might have strong opinions either way, but I think there's a very interesting argument to be had there.
So we're having a really fantastic conversation, but unfortunately we're out of time. So if you could join me in thanking our panelists.
Thank you so much, Arvind, for our wonderful panel. We'll see you at 4:30 for our final presentation.